So, these are some of the things mechanically could subject over iteration with the time, that is a long period of time. So, what are the issues which have been with the ceramic insulators or porcelain insulators are the flashovers. This again flashovers depends upon the pollution areas or contaminated areas where the insulator over a period of time the contaminants get collected on the surface, and in dry season the problem of flashover never happens. In case of the fog, mists or the early monsoon conditions where the surface becomes wet and starts conducting, and the flashovers do happen. We will be discussing about the actual pollution flashovers in future in the next slides, coming slides, why the importance of this phenomena, because where for very high voltages, extra high voltage and ultra high voltage pollution or a contamination which we have identified is a important design criteria to be taken care. So, issues next being the punctures. The puncture of insulators have also been noticed in the field where because of the natural lightning or because of the over voltages or because of very sharp rise of surges which have noticed that the punctures on the ceramic shell have happened and the insulation level has been reduced. Then as mentioned earlier, the cement growth and cracking. Cement growth is again happens because of the expansion due to hydration, which may cause radial cracks or punctures in the head of the insulator. This cement growth where I was mentioning the Portland cement is being used for the pin and the cap. So, this junction where the Portland cement is used over a period of time could lead to the growth and expansion and sometimes a radial crack or a puncture in the head of the insulator or the top surface of the insulator is being noticed. Then pin corrosion, again depending upon the climate or environmental factors over a period of time the corrosion on the pin has been noticed. This could also lead to the failure of insulators or issue with the ceramic insulators. Then long term mechanical and electrical strength reduction takes place because of these issues. And also the coupling hardware corrosion, coupling hardware where the hardware which is being used to connect the insulator to the tower and to the conductor. We have several types of clamps and hardware, a yoke plate, corona control arms and many of these things, hardware which is being employed over a period of time because of the environmental factors could lead to corrosion, and the failure could be seen particularly with ceramic or glass type of insulators. So, these are some of the failures which have been observed over a period of time in the field. You can see the glazing on the insulators over a period of time is completely not available, which will lead to the surface flashover and the insulator failure will happen. So, this again is the puncture of the insulator or the breakage of the shed because of the long period of time which has been served. Similarly, the because of the Portland cement, the cement growth near the pin junction has led to a radial cracks or this may be because of the compressive loads which the insulator has seen this type of failures. This particular figure shows you the cap and pin getting detached, which is known as a donut type of failure where the material detaches itself from the ceramic unit over a period of time, and this is because of the lightning over voltages which the insulator string has seen in the field, where the insulator shed could be shattered because of the over voltages or the very sharp rise in voltages. So, whatever we have seen are the natural things which have happened. This shows again the artificial problems or the man-made problems for the insulator strings which could fail much before their life. That is, reason may be because of the burning of the agriculture waste in a particular areas, or because of the like sugarcane or many other agriculture. After the crop is completed, they try to burn the remains of the things which these cause lot of the dust, a lot of contaminants which go and settle on the insulator surface over a period of time, and they become hardened on the surface, and during the monsoon conditions the surface becomes wet and likely to flash over. So, the second being again some of the brick kilns or a very high polluting areas, industrial areas, where the atmosphere smoke coming into the atmosphere could go and again settle on the surface of the insulators which are nearby to these factories or nearby to these industries, where the transmission lines which are of extra high voltage and ultra high voltage gets polluted, or surface gets accumulated with the pollutants, could lead to after becoming wet could lead to flash over. So, these are again the various types of accumulation of dust on the surface of insulators. Again, this is the bird droppings over a period of time. Many times you must have noticed that on the transmission tower several huge birds make their nests, and try to see the droppings of that will again be settled and get polluted. The insulator gets polluted over a period of time, and this will lose the properties, the insulator will lose the properties, and in case of wetness the entire surface starts conducting and the flash over is likely to happen. So, this is one more example of how the insulator, the dust particularly near the cement factories or because of some quarries, the dust which goes and settles over a period of time makes the insulator completely polluted, and it may lose the insulating properties which it is designed. So, some remedial measures for the insulators. So, much before the monsoon starts, so remedial measures have been done by the electricity authorities or the utilities to see that the flashover does not happen. So, one among the thing is the what you see is the telescope type of the jet which is being used to wash or clean the insulators mounted on a truck. So, this telescopic type of arrangement with water jet at a particular conductive level and try to clear the insulators and see that the contaminants which are deposited over a period of time is done, where in particularly during the pre-monsoon conditions the flashover of insulator is not happening. Again, this is a live line arrangement which has been will be done. The technician or the person who does the operation is on a particular insulated arrangement, where he uses the water jet to clean the post insulator, particularly in the substation or as bushings of the cities, PTs, and several of these things. These contaminants which spread over a time period have to be properly addressed, that is cleaned, so that during monsoon condition the surface of the insulation does not become wet and starts conducting. To arrest the conduction, so proper cleaning of these contaminants or pollutants is essential. So, one is a live line washing which is being shown here in this figure. The live line washing is also very important because you cannot interrupt the supply over a period of time. So, the activity of line washing has to be carried out, which is one of the method to see the flashover of the substation equipment or the switchgear does not happen and during the working conditions, particularly during the monsoon conditions. And there are other methods which are being employed, where areas like high altitude, mountainous areas, or the areas where the vehicle, that is a truck with a jet, could not approach. In such cases helicopter mounted nozzle sets are being employed, and here the help of helicopter mounted jets, the water jets is cleaning of insulators is being done. Even though it is of higher economy involved in these aspects, but the cleaning or the washing of insulator is very important in areas in the forest where the normal truck could not be will not be able to go there. So, such cases helicopter mounted nozzles are being used in high altitude and some forest areas. Apart from this, they are also the trimming of the branches have to be carried out much before the wind or much before the monsoon happens, where this trimming of branches is also very important. So, these are some of the measures which are being employed regularly by the utilities to contain the flash over of insulators. Some again apart from this you see various types of remedies have been employed to improve the performance of the insulator. This is one such small arrangement on the surface of the insulator to increase the creepage of that. Again insulating material which is known as creepage extender is employed to see that the bird droppings or this particular insulator improves for a certain period of time. So, this also has been tried out. Again this is for a substation post insulator which is known as a creepage extender. So, tries to see the flashover does not happen even the surface is become contaminated. This will help partially to see the flashover do not happen. And some designs have also been tried out. This is a without the petticoats where the contaminants does not settle over a period of time. So, such designs have also been tried for the better performance in the field. And this figure shows the transmission lines, particularly in high altitude and very cold areas, that is a high altitude where the temperature is very low and freezes. So, you can see the insulator strings are completely covered with ice and the conductors completely covered with ice. So, this will need lot of revenue particularly for the utilities to maintain, to clean up these things, else the flashover will definitely happen of the conduction of the surface which is in continuously ice formation which is happening in cold countries. So, lot of measures have to be taken by the utility or a transmission engineers which is very important particularly during the monsoon, during the fog, during the icy conditions in the field. So, that was about the ceramic or porcelain insulators which we have seen. A quick look at the glass suspension insulators. Again glass insulators are of very old, like almost similar to the ceramic or a porcelain. They have good contamination performance due to self cleaning properties and they are good for remote areas, particularly with no gun shooting or helicopter patrols, where some people shoot the glass insulator for a fun, where the insulation the sheds shatter and the insulation level decreases. So, again the outer glass, the glass which is being used is under high tension compared to the inner side. Sometimes the failures or a shattering of this happen on the outer surface with a violent shattering of the cell. Sometimes spontaneous failures also have happened in the field. As mentioned, the attractive shoot because the shell explodes. So, some people take it as a fun and try to bring down the insulator or shoot the insulator. Later again the shattered glass is a safety hazard as per again disposing of this shattered glasses is environmental issue. So, this is how not much popular in the US, but still used in Europe, Canada and Brazil and many other countries where the material cost is lesser. And in our country a few of the transmission lines we are also employing the glass type of insulators. So, the final or the recent origin is a non-ceramic insulator or the polymer or the composite or a silicon rubber insulator which are being written or which are being used as a terminology. So, these non-ceramic insulators are again a recent origin and advanced technology, particularly in the insulator field. These were introduced somewhere in 1960s initially for transmission, particularly by the General Electric. Presently being used for all voltages from a very low voltage to up to ultra high voltage levels, and these are light, flexible and have a high strength to weight ratio, that is a very important, and strong in tension and a low degree of standardization. So, this is how a typical polymer insulator looks, Polymer insulator, as I mentioned, will have a fiberglass rod which is shown here in the green color. So, this fiberglass rod is fixed with the metal end fittings. This metal end fittings, one of the fitting is connected to the tower and other is connected to the conductors with suitable hardware. So, the fiberglass rod is connected with the metal end fittings. Later on, with the help of the liquid injection molding, the silicon rubber or polymer sheds or weathering sheds, what we call, are being molded on this fiberglass rod. Again, the length, the type of metal fittings depend on the voltage level which the insulator is being used. So, and the creepage distance of the insulator required. So, all this factor will dictate for various voltage levels. So, these are of recent origin, are being used abundantly in the country and also several other places across the globe, and they have a promising characteristics, particularly for particularly for the pollution performance. They are immediate better performing than the ceramic or a porcelain insulators. So, long term performance, as mentioned, recently a third generation type of insulators are being used. So, we have to have long time data for this, so that it can be exactly compared with the life of the porcelain or a glass insulator. And economic, earlier when the insulators were introduced, the material cost and the insulator cost was very high in comparison to ceramic. Presently, there is the cost has been substantially reduced and it is in par with ceramic, or maybe a slightly lesser in comparison to the ceramic insulator. So, several industries, particularly manufacturing the non-ceramic insulators or polymer insulators, have come up in the country and elsewhere. So, various types of polymer non-ceramic insulators are being used for the various voltage applications. So, service experience, what the utilities have is earlier comparison with the particularly surface degradation, internal degradation, so on. This service experience which have been with the utilities are again from the initial technology which was adopted as a first generation or a second generation. Now, the third generation, much improved insulators are available. So, earlier there were issues, there were some problems. So, some of the or most of the problems are being overcome and few of them do exist. So, we will look into the important aspects where the polymers or a polymeric insulator or a non-ceramic insulator phase in the field. So, surface degradation is the important aspect. The surface degradation may cause because of the ultraviolet rays, this is because of the sun or from the corona of the hardware which we mentioned. Electrical stress, continuous electrical stress on the insulator over a period of time could track or traying. Track or traying is again the slow failure of the insulator surface where tracking could occur and the insulator could see the leakage current flows and the degradation of the material could happen. So, this tracking or traying of the surface could happen over a period of time because of the electrical stress, wherein the leakage current and small arcings which are known as partial arcing or the scintillations could happen, which could result in the flashover and sometimes the mechanical failures because of the surface degradation. Then internal degradation. This internal degradation, we know that internally fiberglass rod is being used where sometimes because of the hydraulic pressure which is being used to crimp the end fittings, the metal fittings to the rod, could lead to a cracked rod or sometimes bad coating between the rod and the sheath. There is a coating which is applied. This could lead to very small voids between the rod and sheath, where the reports have seen or the service experience has seen that the water could enter with the very small blowholes or a hole, and this could, in case of the water entering the surface of the rod, and where the nitric acid is formation is seen, and because of this nitric acid the rod and the sheet failures have happened, where the brittle fracture of the insulating rod could lead over a period of time. So, these have also been seen in the field. So, the result is the flashovers sometimes could be a temporary or a continuous flashovers could happen, line lockouts or blackouts, or the line may give away. So, workers safety concerns are very important. In case of failures, it should not lead to the safety concerns, particularly for our people who are carrying out the live line maintenance. So, very important, these internal degradation or surface degradation have to be seen and addressed. And contamination performance, here initially the contamination performance, what we say is polymers are much better when compared to the ceramic or a porcelain for the short term performance, but later on there are reports which a mold growth has happened on the surface, and sometimes whether this mold growth will likely to create a problem with the insulator. A lot of studies have been carried out on these aspects. We will be looking into the failure where there are problems related to this. And brittle fracture, again I was mentioning brittle fracture, this is again a stress which has happened on the fiberglass rod or a corrosion failure of the fiberglass rod. Factors could be the water entering into the rod because of the mechanical load, electrical stresses happen, and the formation of nitric acid because of this moisture and over a period of time could lead to the fiberglass rod becoming brittle and the fracture also taking place. So, this few of the experimentation which we have also carried out in the laboratory, we will be demonstrating that in the future slides. So, some of the early failures of the polymer insulators which have happened in the field, this may be because of the accumulation of dust, a mold on the polymer or silicon rubber post. So, silicon rubbers could become very dirty due to the strong electric fields. You can see over a period of time the insulator is becoming dirty and the surface getting rough, and where the water droplets starts collecting and the failure could happen. So, these are earlier polymers, but some of them have the improvements have happened over a period. This again is a corrosion because of the end fittings of the polymer rod could lead to the failure of the insulator string. This is again a hardware or a clamps which are being used for the terminations, end terminations could lead failure over the period of time. Again, this is a cracked rod, and these are the older generation of polymer insulators, not the liquid molding machines which are being presently used, liquid injection molding machines. So, earlier the sheds used to be made in a different where it used to be fixed on the surface of the polymer rod. Such gaps or such cracks will lead to the failure of insulator in the field. So, these are some of the exposed because of the damage which has happened. You can see the fracture or a brittle fracture of the rod. This is due to the likely because of the gunshot or the failure has happened. Here you can see that during the manufacturing stages water bubbles or air bubbles during the manufacture, in case the insulators are being used in the field over a period of time, because of the electrical stress these bubbles could break and the water could seep into that and the failure is likely to happen. So, these again are some of the earlier failures of polymer insulators which have been seen by the utilities. Likewise, these are a failure because of the end fittings which the hardware which is being employed for the polymer insulators, and also this is a corona control ring for the non-ceramic insulator or polymer insulator. Over a period of time, this insulator if it is not properly designed and not properly oriented and placed could lead to the continuous discharges, and these discharges on the surface of the insulator could be completely damaging the hydrophobicity effect on the insulator and could lead to the failures. So, these are some of the various failures which have happened because of the electrical stress, mechanical and corona related issues. But when you look into this slide, it may look strange why this slide has been put. So, this silicon rubber, polymer or a porcelain type of insulators, as I was mentioning, is an organic material, very important to take care. So, sometimes the storing of the material is very important. If you do not store in a proper way, they small animals could try to the insulation could be damaged by these things, and also some parrots and huge birds which are normally reside on the tower of the transmission lines would like to peck the surface of the silicon rubber so that they could damage the sheds. This is again a small issue pertaining to the birds and small animals. So, every care has to be taken as compared to the ceramic or a glass insulator. These are to be much more attended in the transmission systems. These are some of the failures which have been reported because of the brittle fracture. You can see after the fourth shed over a period of time, the brittle fracture has happened and the detachment of the insulator has observed in the field. So, very important. So, polymer insulators of present, lot of things have been happening, and with these studies the failures, people have improved their performance, newer technologies are being used, and new type of methods particularly in the manufacturing side are being done to see such failures would not happen, and how for the long performance, long duration or a long period of performance must be reliable. That is one of the important aspect with this type of insulators. So, these are again various failures which have been noticed over a period of time in the polymer insulator. This is particularly for one of the transmission system for a 765 kV line, where the tower failure has happened after 8 to 9 months after the erection. So, very serious concern. So, once the technology which you are adopting have to be carefully also looked, so that equal importance is given not only to the material, the newer technology, the adoption, how it is being used, how it is being erected in the field, what are the orientation of the corona control rings. This has led because of one of the reason being the placement, design and orientation of the corona control rings. So, how corona is important, why it degrades the surface? Yes, as you see here, the corona comes from the hardware. Here you see from the corona control rings. This corona which is generated, the discharges which are continuously discharges are likely to damage the sheds which continuously impinge on the surface of the insulator. Over a period of time, the surface of the polymer insulator, which is supposed to be hydrophobic, loses its properties, and the surface degrades and could lead to the failure of the insulation. So, these are some of the hardware fittings which are used for the polymer insulators. Consist of a yoke plate arrangement for a double tension string. You have a corona control rings with necessary brackets and hardware to fix for the tower end. So, we would like to look, we have seen the ceramic performance or a porcelain performance and the polymer insulators. As mentioned, ceramic insulators are made from inorganic materials. These do not age, they have more than 80 to 100 years experience. Flexibility in length, particularly ceramic insulators, you can have number of discs and increase the length. A high leakage distance profiles could be manufactured without difficulty, and these can be coated and washed at regular intervals of time. So, polymer insulators, these are made from organic materials, they age, that is very important, and approximately maximum 30 years is the period which this technology has started seen, and the latest designs are slightly less than 10 years old. So, it requires lot of studies, lot of field data, lot of field performance of these insulators, so that improvmental design could be carried out, but they have much lighter and less susceptible to vandalism, and they have smaller weaving profile. So, and good short term performance in polluted environments, as I was telling, which will fulfill the criteria for the better performance, particularly for the utilities. They will be very happy to have better performance of the insulator strings in polluted environments. And reduction in weight, again it depends on the voltage level where a comparison could be made, and most of the time the weight reduction is anywhere between 90% and also the reduced breakage, lower installation cost in compared to the ceramic insulators, and aesthetically they are more pleasing, look much better, and also have a better improved power frequency insulation levels. So, this gives you the comparison of attributes for different insulators which are being used for transmission over a period of time. So, same non-ceramic porcelain polymer or a composite insulator, what are the positive attributes and these are the negative. So, as mentioned earlier, the weight reduction anywhere between 60 to 90% depending upon the voltage level and the hardware which is being employed. Contamination withstand has much better comparison to ceramic, low install cost and has better impact strength and small profile, and also cost gets decreased. This is very important. Negative attributes, when you look into the non-ceramic or a composite insulator, they have a reduced strike distance, susceptible to aging because of the material being organic in nature. They are susceptible to arcing damage, a brittle fracture has been noticed over a period of time, and it is difficult to easily interchange the different type of insulators sometimes because of different designs. And as mentioned, they have a limited experience. So, handling, storing, transportation and live line techniques are still to be developed. So, these are very important because the technology is being newer. So, a lot of issues which are cropping up have to be addressed, whereas porcelain or a ceramic performance has been quantified with a long history of use for more than 100 years. But yes, negative attributes being the weight of the string goes on increasing as the voltage level, pin corrosion have been observed, and sometimes cascade failures have happened, and hidden defects could of the material could lead to a problem. And RG porcelain is a resistive glaze porcelain, is the newer version of the porcelain insulators which have been coated with the resistive glaze to improve the voltage distribution on the surface of the insulator and also for better contamination withstand. But again here the price or the cost of the insulator goes up, and sometimes it has been noticed the power loss happens because of losing its properties over a period of time. Glass, again we have seen the spotting of the damaged units. It is very difficult because glass it is transparent, it is difficult to see the exact field insulators in the field. Again it also has a weight comparison to the porcelain, and mainly attractive to vandals, people shoot for fun, and negative perception is the glass is a fragile material. So, these are the major comparisons of the attributes of the three types of technologies or three types of insulators which are being used in the high voltage or extra high voltage or ultra high voltage transmission systems. So, I will compare the working of the technical or technical engineers or technicians in the tower. So, very clearly you can see in case of porcelain insulators for a 400 kV system how much if there are 25 days with the hardware the material weight is very high. This shows the polymer insulators with a lesser hardware and lesser corona control rings. So, people like to work in this area in comparison to this area. So, that the technology has been improved, and lot of new type of polymer insulators are being used for the EHV and ultra high voltage transmission systems.